All right, so here is problem 1J, number 2. And we have the clock, and if you think about the clock, 1, 2, 3, going around the clock. You're told that the diameter is 25 centimeters, so the radius would be half of that, which is 12.5 centimeters. So that's what this part here would be. And we are asked to find what is the length of this arc of this clock going from 12 to 5. So that's what we're looking to do. So if we think about finding the arc length, we need to find out the angle measure and the radius. Those are the two things we have. We have the radius, so now I've got to figure out this angle measure. The clock, the numbers on the clock are equally spaced. So there is the exact same space going between these. So if I have a full circle, that's 360 degrees, and we're going to divide that by 12 numbers. And that's going to give me a value of 30. So the space between from 12 to 1 is 30 degrees, and each one of these is 30. So since I have 5 spaces from 12 to 5, I'm going to times that by 5. And so that gives me 150 degrees of this arc. Now I could just go ahead and use the arc length. I'm going to take the degree, 150. I'm going to times that by the radius, 12.5 times pi, and divide that by 180. And if we do all of that correctly, we end up with an answer of about 32.7, and this was in centimeters. Okay, so that's the first question. Then the next one you had was the chapter review, and that was number 6. And so we're going to take a look at the chapter review number 6. And this one was looking at the measurements for the pool. And your answer from A, first we have this rectangular pool. And here's where your problem, you may find that your answer might not match exactly, and it depends on how you round. And this is why it's so important to show your work. So we have a pool, its measurements are 7.5 by 15. We're looking at finding the diagonal of this rectangular pool. And so by doing that, we're going to use Pythagorean theorem to find this value x. So x squared is equal to 7.5 squared plus 15 squared. And eventually, we're going to find 7.5 squared plus 15 squared is equal to that. I'm going to take the square root, 281.25. And we get this long decimal here. And so your answer, it says to round it to the nearest centimeter. So in this particular case, since I'm coming out to 0.50983, and so it's going to be approximately 17 centimeters if you round it to the back. If you were to round this to 3 significant figures, then it would be 16.8 centimeters. And so these would kind of be the answers that they have. Now, to get to part B, where your question is, it's looking to see the seal. He measured diagonal, and he said it came out to 16 exact. So we want to figure out, we know that this here is the exact answer, and we want to know what is his percentage of error. The book is going to use this exact, and that's how they're going to figure out the answer. This is where things are going to get a little off. So keep in mind, we want to find the percentage of error, it's like we're going to take the approximate minus the exact, divide by the exact, and then times by the 100 to get that answer. So in this particular case, the approximate value is, and then keep in mind, it's all around the absolute value. I think that might be where some of your negative issues come into play. So I want the approximate, and he measured it to be 16. Now your book is going to use this answer, the exact, not the rounded that we got here. So it's going to take 16.77050983 and then it's going to divide by this same value here. Okay, so if that's the case, we're going to take that 16 and we're going to subtract 16.77050983. We're going to get a value. Notice it's negative. We're going to divide that by the exact 16.77050983. And we have this value here. Now, it is going to give you negative, but keep in mind our equation says take the absolute value. So whatever this is, we're going to go ahead and make it positive. I'm going to times that by 100. And so my percentage of error is 4.594432. We're going to go 3 significant figures. So I end up with 4.59%. This is the answer the book has. If you showed the work and you used either the 17 or the 16.8, and say you did 16 minus, say, 17, and then we're going to divide by 17. So again, we're going to take 16 minus the 17. Again, it's going to give me a negative. I'm going to divide by the 17, times it by 100. Now we're going to find, and again, we're going to give because it's absolute value, we're not going to worry about that negative. Now my answer is going to be 5.88% is a percentage of error. And then if you use 16.8, it's going to give you a different. So as long as you show how, which one you used, did you use the actual real exact, or did you use your rounded answer from A, is why you're probably off on your answers. And this is why it is so extremely important to show your work. So if I can see where it is your thought process was, then you don't lose the points, which is the good news. All right, and now I'm going to do number 7. And with this one here, it says Raja is lying tile on a path that forms a diagonal of a square. So here is our square, and we're going to say these are like the tile pieces that he's laying, and they're going to come right across the diagonal. And keep in mind it's a square, which means all 4 sides are equal. Now he knows that the length of this diagonal path is 100 square root of 2. And we want to calculate the perimeter. Now you have one of 2 options. Basically what I'm looking for is some sort of side length. That, either all sides are equal. Here's where your recall from quadrilaterals we did last block 4 is going to come into play. Since this is a square, they're all 90 degrees, and one of the properties is the diagonal bisects, which means this angle measure here is 45 degrees. Because the diagonal bisects that right angle from knowing that property in the past. All right, so now you have 2 options. One, you have a special right triangle, 45, 45, 90 degree triangle. If you recall, these have special things where we have the side, and the hypotenuse is always the side's root 2. So since I have that square root 2, x has to be 100. Now, if that special right triangle didn't come back to you, we can also use a trig function. 45 degrees is what you know. Then we're going to label all of these sides. Over here is the opposite. Here is the adjacent. And this, again, is the hypotenuse. So which am I looking for? I'm looking for the side and the hypotenuse. So the adjacent hypotenuse, that's the cosine. Cosine is equal to the adjacent over the hypotenuse. So I'm going to substitute things in. Cosine of 45 degrees is equal to x over 100 times the square root of 2. In order to solve for x, I need to get rid of this, so I'm going to multiply it to the other side. So I'm going to take 100 square root of 2 times cosine of 45, and then when I grab my calculator, I'm going to put in 100 times the square root of 2, square root of 2, And then we're going to times the cosine of 45, and that gives me a value of 100. So the side length is equal to 100. Keep in mind it asked for the perimeter. The perimeter is the distance around, so if one side is 100, it's a square. All sides are 100, so therefore the perimeter equals 400, and we need to check our unit, and it's in feet. Okay, so these are these three. I'm going to make another video of your next set of questions.